Hey guys, Professor Doney back. We're in the middle of talking about DC circuits, and now we're moving on to resistors and the idea of resistors in series and parallel. This starts getting a little more complicated because it's not just one resistor, one device. We can have multiple, so it's maybe not a complex or complicated circuit, just has a little more to deal with. Now, in series is basically another way of saying in a row. That means I have one resistor going into another resistor, could go into another resistor, and so on. What we have, each one has an ohm value, and if I want to know the total resistance, or what's known as the equivalent resistance, I would just add up all of them together. So it's one after, in series or serial. Think of a serial killer, for lack of a better, one after the other kind of thing. So in series we have there, we just add up. So if these were, for instance, let's say this was a 10, a 20, and another 10, that resistance would be 10 plus 20 is 30 plus another 10, that'd be 40 ohms. And what that means is we could use one single equivalent resistor instead of all three of 40 ohms. Okay? So I can replace all three of those with one single one, but physically or in reality we keep it that way because we have a reason to have it set up that way. Now, moving over and talking about them in parallel means that they sort of branch off. So it comes down and it goes off, and I can go to one, a second, maybe even a third or more, and they come back together. So what happens is as the current comes down here, it has an option of going to the right or left, down the middle, or to the right, or to all three of them, assuming they're all working, and then it all comes back together to exit. So it's sort of like going from one lane to three lanes, back to one lane, where here it's one lane in series, you have to go through all of them. Okay? Now, one little comment here we should know is as we go through a resistor, we do have a voltage drop. So every time we go through a resistor, there's a voltage drop because it has to go all three of them. But when we have them in parallel, what happens, the voltage drop is between the entrance and the exit. So everybody sort of sees the same voltage drop. Here we see different based on what they are. Okay, what changes here is how much current goes through each one. So each of these branches would have a different current, and we're going to talk about that more with Kirchhoff's laws. Alright, so how do we deal with these here? Well, the total resistance or equivalent for parallel is 1 over each of those resistors. And we just add more if we have. Now we could reduce that to say that the equivalent is equal to 1 over each of them. Or we're going to do the 1 overs, add up, and then do a 1 over. So we have that. So in this situation, if we make these, I don't know, let's just give them all, there's a 10, there's a 5, and there's a 20. I don't know why, but we have that. What we would have is 1 over 10, 1 over 5, plus 1 over 20. If we get a common denominator between all of those, it's going to be a 20. We have 2 over 20, plus 4 over 20, plus 1 over 20. That gives us 1 over 6. That's 7 over 20. That becomes 20 over 7. And that comes just about to be about 3 ohms. Okay, a little less than 3 ohms. I don't have my calculator, but it gives us that. What does that mean? That means I could replace all of those with a single resistor. It's about 3 ohms. Now there's a reason we build something in parallel, so that if we burn something out or if this branch goes off, is turned off, we can still have the circuit completed, things will still operate. Just as a note, the old Christmas lights were wired in series, so if I blew out one bulb, guess what? They all went out. And then you had to find which one burned out, which was a pain. Now they make it more in series, so if I lose one bulb, everybody else still burns brightly, but we can see the one that's dead. But what also happens is the current increases in all of the rest of them, so you can burn out more if you don't. So there's a quick thing on series and parallel. Hope that helped you out. We'll see you next video.